For 60 years, scientists could not decide what it was: animal, worm, or mollusk. One fossil, found by an amateur collector in Illinois, has baffled the world's greatest paleontologists longer than almost any creature in recorded natural history. Its full name is Tullimonstrum gregarium, found exclusively in the Mazon Creek fossil beds of Illinois. It lived 307 million years ago, in warm, shallow coastal seas that no longer exist anywhere on Earth. Francis Tully, a pipefitter, an amateur fossil hunter, discovered it in 1958. When he brought it to Chicago's Field Museum, the curators were so puzzled they reportedly passed it around the room, each scientist simply shaking their head in disbelief. The Tully Monster had a long, soft, segmented body up to 35 centimeters long. But its most disturbing feature was a rigid, claw-tipped proboscis at its front end, extending like a mechanical arm reaching outward from its face. Behind its proboscis, the creature possessed eyes unlike almost anything alive today, mounted on rigid, horizontal stalks extending outward from the body, like a hammerhead shark's silhouette compressed into something far more ancient and alien. For decades, Tullimonstrum was classified as an invertebrate grouped loosely with worms, mollusks, and arthropods. The Illinois state fossil since 1989, it remained technically homeless in the tree of life, belonging nowhere with any certainty. Everything changed in 2016. A team from Yale University analyzed over 1,200 specimens using modern imaging techniques. Their conclusion was seismic. The Tully Monster was not an invertebrate at all. It was, they argued, a vertebrate, a primitive fish. The evidence rested on three critical features: a notochord, the precursor to a backbone, traces of gill pouches, and pigment cells in its eyes called melanosomes, chemically identical to those found in the eyes of vertebrate animals today. A lamprey, parasitic eel-like fish that attaches to lake trout today became the closest living comparison. The Tully Monster may have been an ancient, free-swimming relative, navigating Carboniferous seas 307 million years before the Great Lakes existed. But the story refused to end there. In 2019, a second major study directly contradicted the Yale team. New analysis suggested the eye structure and body organization were more consistent with invertebrates, reopening the question the scientific community thought was finally settled. The disagreement exposed a deeper truth about fossil science. Soft-bodied creatures rarely survive the fossilization process intact. What remains are impressions, chemical ghosts in stone that different researchers can legitimately interpret in fundamentally different ways. The Mazon Creek fossil beds are extraordinary. Preserved by an ancient geological accident, organic matter buried rapidly in iron-rich nodules called siderite, they capture soft tissues that would vanish in almost any other environment on Earth. Over 100 species have been recovered from Mazon Creek. Yet the Tully Monster remains the site's most famous and most contested resident. No other fossil bed in the world has produced a single specimen of it anywhere else. What did the Tully Monster eat? Its grasping proboscis and forward-facing eyes suggest an active predator. Scientists hypothesize it hunted small, soft-bodied prey, snatching them with precision from the sediment or open water. Its swimming motion remains debated. The segmented body and a tail fin suggest an active swimmer. Some researchers propose an undulating motion similar to modern flatworms. Others favor a more muscular, fish-like propulsion powering rapid directional movement. The creature likely inhabited nearshore marine environments, shallow, warm, nutrient-rich coastal lagoons protected from open ocean energy. This setting explains both its preservation and its apparent absence from deeper or more exposed ancient marine deposits. The name gregarium, meaning common or abundant, suggests Tully monsters were not rare in their time. Hundreds of specimens exist in museum collections worldwide. In its own era, this bewildering creature may simply have been an ordinary fact of life. Modern imaging technologies have given paleontologists tools Francis Tully could never have imagined. Yet they have produced more questions for this creature than answers. What makes the Tully Monster philosophically significant is what it reveals about the limits of classification itself. Life does not always arrange itself into the tidy categories science needs. Some creatures simply exist outside the boundaries we draw. Illinois declared it the official state fossil in 1989, cementing its cultural identity even without scientific consensus on its biological one. The Tully Monster appears on merchandise, murals, and school curricula, beloved precisely because it refuses to be understood. A 2023 analysis introduced yet another hypothesis that certain features of the Tully Monster's eye structure align most closely with cyclostomes, a group that includes both lampreys and hagfish, reinforcing but also complicating the vertebrate argument simultaneously. 307 million years of silence, and still the Tully Monster refuses to confess what it truly was. It swam, it hunted, it thrived, and then it vanished, leaving only a shadow pressed into gray. New Mason Creek specimens are still being studied. New imaging technologies emerge each decade, and somewhere pressed into a nodule not yet cracked open, there may be a Tully Monster so perfectly preserved it finally answers everything. The Tully Monster teaches us that discovery is not always resolution, that naming something does not mean understanding it, and that the planet's most profound mysteries are sometimes not in distant galaxies but preserved in the rocks beneath our feet.